state of health is a state of function, structure and function, right? So if you're unhealthy, you have unhealthy cells. If you're healthy, you have healthy cells. And what does that mean? It means all the different cells that have, by the way, the cells in your body are all genetically identical, but have very different structure and functions based on which genes in those cells are being expressed, which I'll get back to in a second. But basically, health is structure and function. So if you have healthy structure and function, you're healthy. If you have sick structure and function, you're sick. So the question is, what determines structure and function? And the thing that determines structure and function, now, what determines what kind of, in other words, the genes that you have determine that you can only express human structure and function, right? But the quality of that structure and function isn't determined by the genes that you possess. It's determined by which genes you are expressing. So for a long time, when people study genes, they used to wash off this protein coat on the outside so they could look at what they thought was the important part, which was the genes, that double helix, that famous double helix of Watson and Crick. But what they realized later was what they were washing off was what's called the epigenome. And the epigenome is this coating that goes around the genes. Now, remember, the genes are a recipe book, okay? So what the epigenome does is it determines which pages are available to be copied and taken to the kitchen. Okay. So what the epigenome does is it turns the pages, depending on the configuration of that epigenome, it determines which genes can be expressed. And maybe the best way to explain this very simply, Ari, is to say, we can all agree that all our cells are genetically identical, correct? Because they're all copies of that original cell that we had. So every cell in our body. So imagine this, the cells that make up your teeth are genetically identical to the cells that make up your eyes, which are genetically identical to the cells that make up your heart, which spontaneously depolarize, which are genetically identical to the cells that are in your intestines, that are identical to the ones that are in your pancreas and produce insulin, that are identical to the ones in your bone marrow that produce red blood cells, that are genetically identical to your neurons that produce electricity. So if you were to look at cells, right, under a microscope, and you look at a neuron, you remember, Ari, what a neuron looks like, right? It's got that dendrite and all those things off it, or a heart cell that it's deployed. Like if you looked at the different cells of the body under a microscope, and not in a million years would you assume that those things are genetically identical, because they have such different structure and function, okay? Which proves that the genes that those cells possess do not determine the structure and function which they're expressing. What determines what the structure and function that they're expressing is which genes they're expressing at that moment. So eye cells are expressing eye cell function and structure genes. All the rest of those genes are in those cells, but they're being covered up by that epigenome coat. And if they're covered up, they cannot be transcribed or copied and taken to the kitchen, which is the ribosomes and the cytoplasm of the cell for people who follow it. So if you go to a bone cell, the bone cell has all the genes in there for eye structure and function, but those ones are being covered up by the epigenome, and what's being expressed are the ones for bone cell structure and function. Easy enough to understand?
Yeah.
Okay. So what we now know is what we've now proven in the study of epigenetics, now proven beyond any shadow of a doubt, is that we know that it's the genes that you're expressing that determine your state of structure and function, whether it's healthy or sick, not the genes you're possessing. The genes you possess determine that you can only express human structure and function. But whether or not you're expressing healthy or sick is based on which particular genes you're expressing. And which particular genes you're expressing isn't controlled by which genes you have, right? Which page the recipe book is turned to, and therefore which recipe gets cooked up at the kitchen, isn't controlled by the recipe book. The recipe book is just a passive source of information, which has all the recipes and the ingredients list in it, and that's what your genome is. So that genome, your genes that you possess, have the recipe books, the ingredients list, but who's the master chef? The master chef is your organ of self-regulation, your subconscious brain. So if you look at these variables that determine health, the genes you possess, obviously, because you can't express one you don't have, the kitchen itself, do you have a good kitchen to bake up these recipes properly, to create the proteins and the hormones and all these other things? Do you have a good master chef that knows which recipe to create based on environmental demand? All of those three things, Ari, have been perfected over millennia of natural selection. We don't have faulty chefs. we don't have bad recipes, and we don't have faulty ingredients lists. Correct? All those things are basically constants. So they can't be the thing that can determine whether you can be healthy and sick, healthy and sick. And we all know that our health can change throughout our lifetime. The one thing that is plastic, that is not constant, is whether or not those ingredients are supplied. The shopper is the thing that determines which genes we express, which habitat we shop for, and which choices we make within that habitat are the only variable that determines health that's not constant. Correct? Because all the other things are part of the genome, right? They're constant. Your genome doesn't change throughout your lifetime. But the shopper, right? What foods we eat, how we move, how we think, how we socially interact, what environments we choose to live in, that's the variable that determines our state of genetic expression. And it's our state of genetic expression that determines our states of structure and function. So that's why I say our physiology, which is our state of structure and function, is the epigenetic expression of our habitat and lifestyle.